Okay, section 2.6, quadratic functions. A quadratic function is one in the form of, as you can see, f of x equal ax squared plus bx plus c, where a, b, and c are real numbers, and a is not 0. Again, if a is 0, 0 times h squared would be 0, and this would be a linear function and not a quadratic function. So a cannot be 0. By the same token, b and c can be 0, no problem with them being 0, but a cannot be 0. So you have this expression, this quadratic expression for the function. Lots of uses of this. When you graph a quadratic function, you get a parabola, which is a U-shaped curve or upside down U-shaped curve. It's going to be symmetrical around the axis, and that goes through the vertex, which is the extreme of the function. Here you can see it will tell you if a is negative. Again, a is referring to, see here you have the quadratic function ax squared plus bx plus c. A is referring to the coefficient of x squared. If a is positive, you get a U-shaped curve. In other words, your function has a minimum. And then if a is negative, which means coefficient of x squared is negative, right? Then you would have, your function would have a maximum, and you would have an upside down U-shaped curve. This would be the top. The top and the bottom, the extreme of the function, whether it is the minimum or the maximum, is called the vertex of the function. And it is important to find those. Another thing is that the function would be symmetrical around the axis that goes through these vertex. So same on this. It is symmetrical, which means if you take if you take a line going like this, that means the distance between here and here is the same as the distance to here. So this is equal to this. Same thing on this one, around this axis. This is equal to this. So from this point to this point, at any point, right? So it is symmetrical. Axis of symmetry is called the vertical line that goes through the extreme of the function, axis of symmetry. Properties of the quadratic function. F of x equal ax squared plus bx plus c. The domain is the set of all real numbers. That's point number one. The domain is set of all real numbers. So anything from minus infinity to plus infinity, minus infinity to infinity, would be part of the domain of this function. Again, it is obvious, as I said before, only when you have a rational expression, which means you have a denominator here, you have to worry about denominator being 0. That's what limits the domain of a function. Also, if you have square root or even root, that would limit. So here you don't have any of them, so the domain would be set of all real numbers. That's the first characteristic of a quadratic function. The second, the vertex is at minus b divided by 2a. That's the x value. And the y value would be f of minus b divided by 2a. Right? Now, again, where this minus b divided by 2a comes, if you recall, when you set this equal to 0, x would be equal to minus b plus or minus square root of b squared minus 4ac divided by 2a, right? So this minus b divided by 2a comes from this formula. It is this part of it. So it doesn't have the plus or minus. And this plus or minus, since it is exactly the same amount, whatever this amount is make it symmetrical too. So that much added or subtracted on both sides, so it would make the shape of the quadratic function when you graph it the way it is as a problem. So that would be the vertex, which means the extreme of the function. The axis of symmetry is x equal minus b divided by a. We saw it in the picture. It goes through that point. And the intercept are found by solving for f of x equal to 0, which basically means using this formula, the whole of the formula, set it equal to 0, and then solve for x. That would give you the x-intercept. For the y-intercept, however, it would be f of 0. So f of 0 here, f of 0, that means a times 0 squared plus b times 0 plus c. That they would be 0. So f of 0 is c. This is y-intercept. So you have the x-intercept coming from here, the y-intercept at f of 0, evaluate whatever function you have as 0, you get the y-intercept. So these are helpful hints between the vertex, the x-intercept, and the y-intercept. You should be able to graph your quadratic function. So given the quadratic function f of x equal 2x squared minus 6x minus 1, find the vertex. So the vertex, the x value of the vertex is minus b divided by 2a, and minus b is referring to the coefficient of x. So minus 6 divided by 2 times 2, which is the a. So that would be 6 divided by 4. That would be 3/2. This is the x value. And to find the y value, you evaluate the function at that 3/2. 3/2 equal 2 times 3/2 squared minus 6 times 3/2 minus 1. 2 times 9/4 minus 6 times 3/2. That would be minus 9 minus 1. 2 times 9/4 is 9/2 minus, well, 9 and 1. That's minus 10. So 9/2 is 4.5 minus 10. So that would be equal to minus 5.5. So the vertex has a coordinates of 3/2 and 5 or 5.5 or 11/2 if you want. 11/2. Right? So x is equal to that, 3/2. You plug in for x 3/2 in the function, you get minus 11/2. Did I get minus 11/2? Yeah, it should be minus 11/2. I think I made a mistake. Minus 11/2. So this is the vertex of that function. Find the intercept. For the intercept, you set this equal to 0. So 2x squared minus 6x minus 1 equal to 0. You can find using the formula x equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So that would be equal to minus b is 6 plus or minus square root of 36 minus 4 times a, which is 2, times c, which is minus 1, divided by 2 times 2. So minus 1 minus 2 minus times minus 4 is minus plus 8. So you have 6 plus or minus square root of 36, and 8 is 42 divided by 4. Okay. So those are the two answers. See what they did. So a is equal to that, and they simplify that, and it would be 3 divided by 2 square root of 11. When you simplify it, it would be that. Okay, let's see. Let's see what is the square root of. I want to graph this. Let me just this instead of 3/2 write it as 1.5, and minus instead of 11/2 write it as minus 5.5. And square root of 11 is approximately how much? 3.3. I just try to find some approximation. 3.3. So you have the two answers. One is 3 plus 3.3 divided by 2. Let's make this 3.4. So it is 6.4 divided by 2. And the other one is 3 minus 3.4 divided by 2, which is minus 0.4 divided by 2. So it's minus 0.2 here, and here is 3.2. So these are the let's see if I can keep those as my answers. Yeah, I can keep, oops. I can keep them. Okay. So if I do Cartesian coordinate x and y, first I find this, the vertex, right? So 0, let's say 1, 2, 3, 4, 1, 2, 3, 4 on the vertical axis. Let's say this is 5, this is 10, minus 5, by the way, minus 10. Here is 5, here is 10. So what we're gonna have is the vertex is at 1.5 and minus 5.5. 1.5 would be here, minus 5.5 would be would be right here. This is the vertex. And since A is positive, it's gonna be coming up at 3.2 and minus 0.2. If this is 1.5, this is 3.2 probably here, and minus 0.2 probably here. And by the way, the f of x would give me, f of 0 would give me minus 1, which is the y-intercept at minus 1. Let's say this here, and this is minus 5. So this will go up in this direction, and it will go up in this direction. So that's what the shape of this function would be, given the vertex as 1.5 and minus 5.5. Approximately this, because we made these numbers on approximation of square root of 11, we made it to be 3.4. Okay. Another quadratic function, we can use it for supply and demand. With supply and demand, we can talk about linear function, which is what we did, finding the intersection of the intersection of the two, supply and demand, which is called the equilibrium point. Or here we would have a quadratic supply and demand. So first definition, a demand equation expresses the relationship between unit price of a commodity and quantity demanded. So price as a function of quantity demanded, and supply equation expresses the relationship between the unit price and quantity supplied. That's the difference, quantity supplied or quantity demanded. One would make it demand, the other one would make it a supply. Right? But both of them is talking about the relationship between price and quantity, right? So both of them would have the same look to them. Here's an example. It says the demand function for a certain commodity is given by price or demand as a function of quantity, but that's what x is, which is the same as a price. I assume we should write this as a price as a function of x also. Price would be this function. The question is, where price is where P is the price in dollar, H is the number of units demanded. What is the maximum demand? Well, first of all, this we know is gonna be a quadratic function. It's gonna be an upside down U-shaped curve, and this is the graph of it. You're not gonna go through this step, but what you need to do is you need to find the vertex, which would give you this, the maximum of the function, and you also need to find the x-intercept and also the y-intercept. The y-intercept is clear to see, is right at 10. That's what this is. The y-intercept, the x-intercept here and here. Now, this is this whole function, but the part that is interested as far as economics is concerned, since price and quantity, none of it can be negative, then the part of this function that we have, which would be the demand, is actually this in the first quadrant. This. The rest of it is irrelevant. Because down here we are talking about, by the way, this is the price. Down here we are talking about negative price, which doesn't make any sense. To the left we are talking about negative quantity, buying negative quantity, which doesn't make any sense either. So the only part which is interested as far as demand is concerned is this part in the first quadrant. So they went ahead the way they find the intercept. First of all, they went and got rid of this fraction or this decimal by multiplying everything by 100. Since this is 0.01, multiply everything by minus 100. So when you do minus 100, this would be positive 1. Minus 100, it would be plus 30. Minus 100, well, this is where they made the mistake. Minus 100 times 10 is minus 1,000, not 100. Then you factor this out. It would be x plus 50 times x minus 20, right? So you set each one of them equals 0. So x plus 50 equals 0. That gives you a minus 50. X minus 20 equals 0. That gives you 20. So since quantity of negative does not make any sense, you would disregard this answer. So the answer is 20. That is this point. This is 20. So the question is, what is the maximum demand? The maximum demand is 20 units, and that happens when the price is 0. It's on the x-axis. That's what we did here. We find the x-intercept. The intercept one is at 20, the other one is at minus 50. Okay. So here we talk about market equilibrium, where demand and supply is nonlinear. It says, first, the definition of market equilibrium. Market equilibrium occurs when the quantity produced equal to the quantity demanded. The quantity produced is equal to quantity demanded. That means whatever is being produced by the producer is being demanded by consumer, right? So there is no surplus, there is no shortage of that product. So basically, graphically, that would be the intersection of the two, intersection of demand and supply, which is right here. By the way, this is price. They have it as y. The price is shown at the y-axis. This would give you equilibrium point, which says the quantity is this many and the price or x star. That is the quantity. Here's an example. Given the following demand and supply functions for a certain commodity, find the equilibrium price and the quantity. So price is as this function, right, which is the same thing we had before. Supply is this function. Okay? P is measured in dollars and X is the number of units. We want to find the equilibrium price and quantity. That is the intersection of the two, and we already know to find the intersection, we should have to set the two functions equal to each other. Again, since the left-hand side of both is price and they're equal to each other, then that means the right-hand side should be equal to each other. So this would be equal to this. So we set them equal to each other. This is the first one, the left-hand side, equal to the second one. Right? Now, simplify. You come up with this quadratic equation equal to 0. Now you have to solve for it. Before we solve for it, we are multiplying everything here by 50. Multiply everything by 50. So 50 times 0.02 would be 1. 50 times 0.1 would be 5. 50 times 3 is 150. Signs remain as they were. Now this you have to solve for x, which is x plus 15 times x minus 10 equals 0. That means x plus 15 equals 0 or x minus 10 equal to 0. One would give you h equal minus 15, the other one would give you h equal to 10. Again, minus 15 is unacceptable because you cannot have a negative quantity. So the answer is plus 10. That's the quantity, 10 units. To find the price, we go and plug it into one of these equations. It doesn't make any difference which one. You plug in 10 into one of these equations. So it would be 0.01 times 10 squared minus 0.2 times 10 plus 7. So 10 squared is 100. 100 times 0.01 is 1. Minus 10 times 0.2 is 2. Plus 7 equals 7 and 1 is 8. Minus 2 is 6. That gives you the price. The price will be 6. That's how you find the equilibrium. 10 units and sell it for a price of 6.